Now, who has questions about this? Where did 2y come from? 1y, 2y. That length is 2y. Okay. So without further ado, I'm gonna put you against an infinite equation and see how you fare with it. You have 10 minutes to solve this one. Oh, sorry, the dots aren't too visible. When is the re-exam? That's a very good question indeed. I will figure it out while you solve it. Interesting. X in power X in power X in power X in power X. Okay, these are 4 points, only 3. In power X in power X in power X. Any amount of times that you want is equal to 2. So I'm going to give you a bit of trivia about this equation. if you put a finite number of x's here, it has no solution. And now, in the meantime, I'm going to write to your examiner and see if I can get the dates for the exams, because they are not in the study guide, and that's strange. That's very strange indeed. You think you will fail tomorrow if you get that question on the exam? Well, this is actually your lucky day, because if you get exactly this question on the exam, you will already have solved it. And a ridiculously high amount of other complicated equations, accidentally. So I'm going to give you a hint, small hint here. I'm going to name all this equation as EQ. Jonas Sjöstrand is indeed the examiner. So the exam dates and all that are ultimately up to him. I am currently unaware of re-examination. Almost there, almost there. You pretty much got it, sir. So I'm going to write your conclusions here and see what happens. That's the opposite of what you had in mind. Then what did you have in mind? I thought about simplifying the left-hand side. You have a problem with the left-hand side. And that is impossible to simplify. However, you got the idea there. from these two, you get EQ equal x squared. Good, good, very good. You're getting closer. Now, what do I do here? How close are we to an actual solution? Yes, we do. Good. Now, one more question regarding this equation. I've only told you that x is a real number. Do we admit the negative root or we don't? Also, this arrow looks terrible, and you didn't tell me anything. No. Okay, so let's follow our steps. We consider x in power EQ because we know it's a EQ is a positive number. We know it's 2, so we can do that. We have x in power EQ is x squared. Now, think here that exactly we have an infinite amount of x's. So if we take the exponential, this thing remains. Infinite x's. And so x in power, this tower is exactly this tower. It's a fixed point for the exponential, which you will probably see in a couple of weeks. From here we have x in power of this tower is equal to this tower, but this is also x squared. And so this thing right here is also x squared. And so we plug everything together. We have EQ equals x squared, but what's the particularity with EQ? And it's equal to 2. And when you put everything together, You have a super nice quadratic equation that kind of solves itself, but still, you haven't answered me this question. Do we admit the negative solution or don't? Ah, okay. I actually can't explain you why, because we haven't seen successions yet. But the idea of this tower is that x always has to be positive, because if you evaluate this for fixed values of x, this goes up. But if you put here y and here you put the number of x's, then you will see that the value of this tower does something like this. And here we would have x0, here we will have x0 in power x0, here we will have x0 in power x0 in power x0. This is 1, this is 2, this is 3. So this, if you fix the value of x, this castle of exponents is what is called a succession. And one of the conditions for all this thing here to be positive is that the base value here, in our case x, is also positive, because otherwise it's incredibly difficult to evaluate the value of these castles. And so at some points it can be positive, at some points it will become negative. It will do something like a sound wave that is very weird. And in some cases, for example, this is not a real number. This is a complex number. So it will be basically impossible to evaluate the full castle of exponents. So no, we don't admit x equal minus square root of 2. So we have exactly one solution. Now I owe you guys an apology, because I really thought we have done successions already. So there's some things I actually can't tell you about. And once you do successions, you will probably be able to solve problems like this in a whim. Also, for the anecdotal value of it, this equation only has a solution if this is equal to 2 or if this is equal to 4. Now, okay, now we've already had some fun. Now let's go back to the exam that you have tomorrow. So questions, exercises, things that you don't kind of get the grasp of, and that we are still in time to solve. Now is the time. Question 1 from exam 1, January 7, 2020. Let's see. Okay, what is the, oh, okay, here we are. So we have a square. And we know that the area, I closed it accidentally instead of minimizing. Thank you for nothing. The area increases by 50 square meters per second. So the area, which is L squared, we know okay. We are wondering how fast does the perimeter of the square increase? So by using implicit derivation, we know that the area changes with time. So the side changes with time. So L depends on time. L is an L of t. So this is the derivative of a function of t. So we do implicit derivation. We have 2 times L derivative of L. From here we can cancel this thing with this thing. And here we get a 25. And I'm going to write this down better. L dl dt equals 25. So we wonder how the perimeter changes. The perimeter P is 4 times L. Side plus side plus side plus side. Zero mistake here, nothing new under the sun. So the perimeter changes something like this. It's 4 times the side, it changes at 4 times the speed, it makes sense. Now I'm going to do a small transformation here. Now we express how the side changes in terms of the own side, which is great. Now we plug this. We know how the side changes, and we plug it into the equation of how the perimeter changes. And we have that the variation of the perimeter is 4 times 25 divided by L, which is 100 divided by L. Now, we keep reading the question. It says, at the moment where the area is 25 square meters. Now, initial conditions. We know that the surface is 25 square meters. What's the side of a square with area 25 square meters? 5. 5 squared is 25. That shouldn't be a problem. And now what we have here, we have the value of L. So we can calculate how the perimeter changes. And we are done. Same paper exercise 4. If I remember correctly, I have done this already. Anyway, we can do it again. Now, before I delete it, questions about this exercise. Where is the complication? Where is the point where you say, it's taking me so much to jump? Okay, good. Oh, I'll show you why. That actually has a very easy explanation. Now, exercise 4, we know that we are moving in this line to x cubed plus 2x squared minus 12x plus 23. Okay, I will get there. We're going to do the full thing again and see where the difference is. Now, if you have a point in the space x0, y0, and this is the origin, the distance to the origin of this point is, by the Pythagorean theorem, a square root of x0 squared plus y0 squared. Okay? By using this, if we have any point of the curve, the distance to the origin of that point is the square root of x squared plus y squared. Now, what's y squared? Y squared is all of this. So this is the square root of x squared plus 2x cubed plus 2x squared minus 12x plus 23. X squared, 2x squared. They add up. Now, questions here. This seemed to be a very big contingency point, but you have to remember where the thing comes from. Like these coefficients are not for free. This comes from the function, and this is x. So now, so now I'm going to be working with the distance squared, and we want to minimize this function. So we try to minimize d0 squared. With respect to x, and that's 6x squared plus 6x minus 12, which is equal to 0 if and only if x squared plus x minus 2 equals 0. And from here we have x is minus 1 plus minus the square root of 1 plus 8, 9, divided by 2a. So we have x equal minus 1 minus 3, 24 divided by 2 minus 2, and minus 1 plus 3, which is 2 divided by 2, 1. This solution we rejected because it doesn't belong to the interval we are moving in. Okay, so apparently my computer fell in the good old school trick of restarting Zoom because it wanted to. So hopefully the recording will not be harmed. And what I was saying is that we try to minimize the square distance. We get this polynomial, solve it. We have two solutions, 1 and minus 2. We stick to x equal 1 because x equal minus 2 is not in the interval we're considering. Apparently, Mahmoud, Zoom just restarted itself. It closed down and then opened up again. Is this correct? It should be. Okay, so that is the distance to the origin. That's a minimal distance. And now we have to look at the sign of the derivative. We have x equal 1 here. If x is smaller than 1, for example, 0, this is negative, so it comes like this. And if it's greater than 1, this thing is greater than 12. So it goes up. So this is a minimum. And for the maximum, we have to examine the other possible candidates, which are -1 and 2, the extremes of the interval. We know that the distance is greater in both extremes, so we have to see what happens in each of them. In x equal -1, this distance is -2 plus 3 plus 12 and plus 23, which is 35, 38, 36. And finally, if x equals 2, the square distance is 16 plus 12 minus 24 and plus 23. This is -1, 11, 27. So what's the maximal distance? And what's the minimal distance? Okay, so it seems like we went a little bit over time, so let's take 10 minutes. We'll be back at 11:17 with more math, probably. No. So yeah, no. The thing is, we figure out a variable that depends obviously on this, and then we derive with respect to that variable. In our case, the height, because we can play to maximize both the radius and the height in order to maximize the volume. So I guess we can all agree the main difficulty of this problem is actually posing the problem into mathematical terms. Here there's a lot of things to take into account. Here you could do this with h and r instead, and here you will get the square root of r squared minus r squared and derivate everything with respect to the small r. That could work as well, but since h is not squared, r is squared, and we have the Pythagorean theorem here, we find it more convenient to directly pay with the square amounts. More questions? Okay, no questions. I don't know if I should be very happy or very scared. But if it was the second, please tell me and we will solve anything that comes our way. We could solve extreme value problems. We absolutely could solve extreme value problems. Okay. So we start with number 5. We have two non-negative numbers that we will call A and I don't know, 10 minus A or something like that. And we want to minimize or to maximize, to minimize this thing right here. So one very common trap is that you call this B and then you don't know what to do. But then it's when the problem says two non-negative numbers that sum 10. So one is whatever, and the other is 10 minus the first. So let's see. I don't know, I'm going to call this S. And the derivative of this, we derivative with respect to E. There is absolutely no mystery in this. And now we want this to become 0, which means 3a squared plus 2a minus 20 equals 0. We solve this equation. We have a equals minus 2 plus minus the square root, b squared, 4 minus with this minus becomes a plus, 4, 80, 240, divided by 2a, 6. So this is minus 2 plus minus the square root of 244. I'm going to try and simplify this root. This is minus 2 plus minus. This is prime. And here we have two solutions. One is positive and one is negative. We remain with the positive because the problem asks us to. So a is minus 2 plus 2 square root of 61 divided by 6. So square root of 61 minus 1 divided by 3. A is that thing right here. This is something between 5 and, no, sorry, it's something between 7 and 8. So this thing is positive. Now we try and find the second derivative and its sign to see whether that is a maximum or a minimum. This is 6a. This is greater than 0. This is greater than 0. So this is greater than 0. So a equal square root of 61 minus 1 over 3 is a minimum. And now all that is left is to calculate this thing, because we're asked for it, and the minimum sum is a square root of 61 minus 1 over 3 cube plus 10 minus a square root of 61 minus 1 over 3 squared. You plug that into a calculator and the result is whatever number you get. There we go. Oh. Now, anybody has questions about this exercise before we move on? Could we also do some limits to infinity? Yes, we could. let's see. So we are going with some custom-made limit. Now what happens here? So in order to solve this exercise, who tells me the domain of that function? No. The domain of that function is not minus pi over 2, pi over 2. That's more like it. So with this in mind, who tells me the value of this limit? Nope, it's not 1. Nope, it's not 0 either. It's not undefined. It doesn't exist. The limit is out of the domain, so that function is not defined. It's not that the limit is not defined, it's that there is no function. So besides these inverse trigonometric functions, bring us very little joy in terms of limits. In an exam, you can write the limit does not exist. If the limit does not exist, you will be right. But you have to argue why. So moving on, we have another funny one. That's limit when x tends to 0 of the sine of 1 over x squared. Who tells me the value of that limit? The value of sine is approaching 0. The value of sine is always between -1 and 1. So nope, that doesn't give you the information we need. No one? Okay. This function has no limit in 0. If you were to plot it, this is 1, this is -1. It does something like this, but then it gets sharper. And it oscillates there infinitely. That's more or less the sign of 1 over x squared. Now, related to this, the last one for today. What's the value of this limit? Marco, are you there? Apparently not. Who tells me the value of this limit? Good. This is 0. This function is something like this. Very good. Very, very good. Is it possible to prove with calculations? Well, yes. Yes, it is. However, we have to resort to something called the squeeze lemma. We know that. And so we take limits. Now, this limit is 0, this limit is 0. And so which number is at the same time smaller or equal than 0 and greater or equal than 0? The nullness itself. So this is how you prove one of these limits with calculations. The idea, function that tends to 0, bounded function, works on just one step, but remember to explicitate it, like this limit is 0 because it's a function that tends to 0 times a bounded function. And the true mathematics behind it is actually this squeeze lemma. In Spain, we call it the sandwich lemma, which kind of sounds a little bit yummier, but the idea is the same. You try to catch your limit between two things that have the same value. So at the end, you just hit the value of the limit. Unrelated to limits. Yes, I do. So let's see what we can do. We have these three functions: secant, cosecant, and cotangent. And you don't really need to memorize derivatives for those things or anything. I mean, secant is cosine in power minus 1. Cosecant is sine in power minus 1. And this thing right here is tangent in power minus 1. Sorry, the room is full of dust. So if you want to derivate this, this is a composition of functions. You have cosine of x as your inner function and power minus 1 as the outer function. So the derivative is minus cosine x in power minus 2 times what is inside, which is sine x over cosine squared. If you do the same thing here, minus 1 sine x in power minus 2 times cosine x. And this is minus cosine x over sine squared of x. And this is minus 1 tangent of x minus 2 times the derivative of this, which is 1 plus tangent squared. So this is minus tangent of x in power minus 2 plus 1 minus 1. Is it worth it remembering them? No, it's not. I mean, I don't remember them. You remember the definitions. Secant is 1 over cosine, cosecant is 1 over sine, and cotangent is 1 over tangent or cosine x divided by sine x. And that's how you do it. You really don't have to overload your brain with a needless amount of formulas if you know where the things come from. And if you want to go one step forward, and you have, I have done this already, but if you want to find the derivative of this, you already know this is 1 over 1 minus x squared, but it makes no sense. If you want to derivate this, you go here, you apply implicit derivation. So 1 is y cosine y. Is this true? No, it's not. Sí, ¿no? Right. Sorry, it happens sometimes. So from now, you have y prime is 1 over cosine y. And this means absolutely nothing, but here you remember the most important trigonometric identity that says cosine squared plus sine squared equal 1. And this makes it 1 over the square root of y minus sine squared of y. But what is sine squared of y? X squared. And that's how you get it. So you can do this in 30 seconds, or you can try and remember the formula. The main difference is you will probably forget the formula after the exam, and this is forever. Like, I don't know the derivative of the arc sine because I don't give it any space in my memory. I do this every time I need it. And you can do basically the same with every function that looks a little bit quirky, but it's famous and or has a name. You just don't have to memorize it most of the time. I don't. When you are fighting integrals, there will be a point where you have to use this, but we will get there. We will get there. Okay, so if anyone has any more questions to ask, talk now or forever keep silent. Will I upload today's tutorial on Canvas? Yes, I will. As soon as we finish this class, I will go have lunch and upload everything after. Now you should be able to access all tutorials until number 9 already on YouTube, and I will upload this one as well, and you can follow it in the same link. And with that being said, let me consult the time and the place for the exam, because it's literally not the first time that I arrive at an exam, and I go to the wrong room, and it's slightly uncomfortable, honestly, when it happens. Will I be at the exam tomorrow? I think I have to. I'm not sure. Like if it's not me, Ashraf will be. But currently, I cannot tell you. We'll have time for that. Anyway, so I'm actually going to ask Jonas, because there is a big difference between having to come to uni or not. And there's a lot of stuff going on right now. So yeah, my final tips for this exam: study hard, don't obsess with it, go to bed early, take a shower, drink a lot of water. Easy. Like literally, the best thing I can give you is don't overcharge your brain the night before the exam, because when the morning comes, it's going to explode, and you will have shattered pieces all along, and it's definitely not a comfortable situation to be in. When you arrive to an exam and suddenly, boom, your brain explodes, and all that work of the night before was for nothing. If you want to do it efficiently, do something today, go to sleep, get up at 9, give it a couple of hours, and then you can go. And now it's lunchtime, so stay hydrated, you guys.